ethane, something like that.
You want the pure product.
Sorry?
You want the pure product.
Well, the benzene you want a pure product. Light gases you usually don't necessarily need, right? Unless you're going to sell it for, depends on what you're going to do with it. So you're going to put it in a burner to heat up gases, right? You don't really need it. Okay? Make sense? You might be using these light gases within the plant anyway to generate hot water. Right? You can just burn it. All right, so this is basically a very simple block flow diagram. Okay, any questions? And as I said, the idea is to, this already actually tells you a lot if you think about it, right? Yeah?
Why don't we recycle the toluene back into the river?
Back here?
Yeah.
Well, actually, that's what we are doing. Usually what it is there's always a, basically you have to separate. Yeah. Now what do we do here? We have two lines. What do we do?
Go like this. Do like a
Either
half
dot,
circle.
dot, and you just discontinue this and you continue this. So the convention is that whatever line goes straight is not broken, the whatever line goes vertical is broken. Okay, that's a convention of block flow diagram. So there are some, this is just a picture, right? But there are some conventions. All the equipments are shown by blocks. You show only the most important equipment. You can see I haven't shown any pumps, right? I haven't shown any heat exchangers. You never show any of those. Very simple equipment. You write down some very simple mass balances. So like you will put some numbers here. So this will be 10,000 kilogram per hour, 850 kilogram per hour, and then whatever benzene you're generating at 8,200 kilogram per hour. Okay, so you write down the basic numbers. And you also write down, this is of course called, distillation column, right? So you sometimes just call it T for tower. And this is V for vessel. Okay. And then you actually will never draw, you will never try to avoid drawing stuff like this. This line should really go vertically up. So all the light streams go vertically up. All the liquid actually comes vertically down. Okay? Which again is, and there should be arrows on every line. But all of this is really just straightforward, right? There's nothing here that is not, this is recycled streams of that. Okay? So that's your block flow diagram for producing benzene from toluene. Okay, any questions? As I said, if you think about it, this really does tell you a lot because it kind of gives you, like, if somebody were to start building a house, right? I just like the energy of a house. If you go to an architect, I think I gave you this example last time too, an architect, this is the kind of picture he will draw, right? He will show you where the bedrooms are, he will show you what the roof will look like. He's not going to start putting sewage, water lines, right? What kind of cooking range you will have and stuff like that. So this is the kind of picture that an architect will draw you. And that already gives you a great idea what your house will look like, right? You start imagining it. So similarly, just looking at this picture in your brain, you should have a very clear picture of what your plant will look like, what it will do, right? But of course, this picture is not enough to actually start building it, right? But however, what you can do is, at this stage itself, you can cost the plant. You might ask me, how do I cost a plant with such very little information, right? How do you think you will figure out the cost of an entire plant just from this very simple sketch? Sorry?
Start with the block.
But how will you cost a block? How will you cost a reactor block? Right, but I haven't even told you the equipment. So really, if you think about it, think of how would you cost a house. So let's say somebody tells you and says, okay, I want to build a house.
Comparison costs with others, like other houses.
Very good. Comparison of cost with other houses that are similar, right? You're not going to compare to New York City, right? So what information do you think you will need at least to the, so okay, fine, you're building in Gainesville. So let's say you have data for all the houses that were built in Gainesville for the last 10 years. So what do you do? What will you ask me? Sorry, size, right? That's the obvious question. You ask me, okay, what's the size of your house? And based on that, you will be able to give me a reasonable number for my house, provided you have data for similar houses in the past. Does that make sense? So if you were to cost this, what would be the equivalent of a similar house? Sorry? A similar plant, which would make benzene from toluene, right? So you look in literature and you look at data for other plants built that make benzene from toluene, right? And you look at the cost of all of those. So clearly cost will depend on the capacity, right? So now let's say that if I build a house of 300 square yard versus 600, how do you think the cost will scale with the size of a house? Will the 600 be exactly double of 300? Typically it's an exponent, right? Most costs don't necessarily scale linearly. So usually the cost, let's say C is the cost, right? Scales as capacity. So let's just use A for the capacity, or let's just use entropy. I want to use it because C is cost and C and capacity, they both are C and C. Right? Sorry? Well, let's just use A for capacity. Let's just use Let's just use A for capacity. Area, like A for area. For house, it's actually quite relevant. So usually cost will be A to the power n. It's not going to be linear. I mean, linear is also a special case of that. Now, what do you expect n to be? Sorry?
Between 1 and 2.
More than 2? Really?
No, between 1 and 2.
Between 1 and 2. Okay, actually, it would depend on what you're building, right? For houses, I am not sure it will be 1 and 2. Why would you think it will be more than 1? So you can see 1. What does 1 mean? 1 means that, in some sense, the relative increase in cost because of bigger houses, just again, is the same as the initial one. So there is no increase in cost or decrease in cost because of increasing area, right? Why would you think it would be? So one could be sublinear, other could be superlinear. So linear simply means, yeah, nothing depends on more area, more cost, proportionally. If it's more than 1, you are saying building a house is significantly more expensive than just relative increase in area. What would be the extra cost because of the larger area? You may be right. I'm just trying to see what do you think would be that
That's
cost.
Like if larger homes are usually built in a nicer area or like a better area of land or something.
Well, let's say we're not, but actually, you may be right because the roof is one, I think, where if you have a really big house, I don't know, the cost of roof might skyrocket. I still don't think it will be, my guess is it will be less than 1. Okay, yeah?
Are we talking about building costs or market costs?
Let's say either way.
It's like when you look at like mansions and stuff with like.
So my guess, and you can do this search very easily, right? In fact, where would you go if you want to do this search? Sorry? You can do Google, but there's actually a specific website called Zillow.com. If you want to buy a house, you will look at Zillow. So you can go on Zillow, and in a given location, you can look at the prices of various houses. And you will see size versus, and you can draw this correlation, and you can see what it looks like. Zillow may already have such a correlation. My guess is it will be less than 1. I mean, the power will be less than 1. For most chemical equipment, it is less than 1. It's called economy of scales. The economy of scales, basically, the more you make, the cheaper every product becomes, right? So n is called the cost exponent, and for chemical engineering plant, entire plant, now I'm not talking about individual equipment. But if you look at the entire plant as a whole, cost exponent is usually 0.6. Okay? That means it becomes significantly cheaper to make stuff if it becomes bigger and bigger. Okay? What is a classic example of economy of scales in your everyday life? Yeah?
Power companies.
Okay, power companies, yes. Sam's Club, very good. I was thinking of Walmart and Sam's Club, right, which are actually the same company. Many people don't know that Walmart and Sam's Club are same. They're owned by, well, they're not the same company, they're owned by the same group, right? Sorry?
The guy who started it was Sam.
Sam Bolton, yeah. So anyway, Walmart actually can dictate price to vendors. Vendors go, Walmart says we'll buy it, but this is what we'll pay you. Take it or leave it. Everybody says I'll take it, right? Because so that actually leads to a lot of problems sometimes. Why do you think there are problems from that?
Monopoly?
Yeah.
You essentially have a monopoly.
Okay, so what? But they're giving you a cheaper product. As a consumer, why should that be a problem for you?
Because once they figure out competition, there's no reason for them to give you buy a cheaper product. They have no competition.
Very good, because this way they can destroy competition. So a lot of companies who have tons and tons of money, they can sell you stuff at a loss. for a long time, with all the competitors, why? Because the competitors cannot stay in the market for too long. They can't. If somebody is selling at a loss, you have to sell at a loss. If your pockets are not as deep, soon you'll run out of money and you'll have nowhere to go. And you'll close your company, and then the other company can increase the price. I'm not saying Walmart does that. I have no idea. I'm not an economist. Okay, I've not done a research in this area. But nonetheless, that is a problem with the monopolies, and that's why, of course, the government has an entire department that is focused on preventing too much monopoly from developing. But anyway, so the bottom line is that N is less than 1, and it's 0.6 for chemical industry. Okay, so you look at data from plants in the history, and if you look at the plot of log of cost, so log of C, or let's just say log of C, versus log of area or log of capacity. In this case, you could say log of the toluene production rate for benzene. You will see basically a linear relationship. You know your capacity. From there, you can figure out your cost. Right? Make sense? Another way of saying it is that if you know the cost exponent, and if you know the cost of another plant, you can figure it out, right? Okay. But what's the flaw in what I just said? Can you guys, yeah?
That it doesn't work at extremes.
So yeah, certainly there will be some validity to this equation. This equation will not be valid for all different ranges, right? But what else? There are some other issues with this, yeah? Actually, let me ask you first, yeah?
You might not have historical data and similar format.
So that's certainly possible that you may not have historical data, that so you may have data only in this range, and you may be building here or there, so in which case you'll have to extrapolate, yeah?
Yeah, if someone wants to buy at the scale you can produce.
Sorry?
They don't have demand to meet the scale you can produce.
Sorry, I still don't understand what you're saying.
You can't produce 1 billion fire trucks if people only need 10 fire trucks.
No, but that's a separate issue. That comes later. So you have to start with somewhere, and if it turns out you're producing too much, then will tell you the project is not going to be economically viable. Yeah.
The capital cost goes up.
So all those two, but think about one simple. I kind of gave you a hint by saying that if you're going to build a house in Gainesville, you're not going to look for houses in New York, right?
Area cost inflation.
So cost depends so strongly on which place, right? Location. What else? Is the house today going to cost the same as the house 20 years back in time? No. So you have to take the location into account, right? And you have to take the time into account. Now taking location into account is extremely complex. Now you can argue that, well, you will take countries into account in some sense because the data that is coming from you may be all coming from the United States, in which case you're taking that into account. But in general, and that's why costing becomes very expensive very quickly, because it costs money to collect data, it costs money to buy data. Usually you don't have that data. You're starting the company, you don't have this data. You have to buy data from somebody to use. So you have to correct it for the time. And you correct it for time by essentially using a price cost index. So there's a cost index called CEPSI, Chemical Engineering Price Cost Index. And that basically is a table. There's a number for different years. So after figuring out this cost, you will figure this out in certain year based on what year this table was prepared in, and then you'll multiply by the appropriate CEPSI value to bring it back or bring it to the current time. Does it make sense? So what you will do is you will say price 2 or price 1 is first going to be capacity 2 over capacity 1 to the power n, right? You take into account the area or the capacity, and then you'll multiply by CEPSI, Chemical Engineering Price Cost Index at 2, by Chemical Engineering Price Cost Index at 1. Okay? Make sense?
So what do you do for location? Is that just like?
You just, you look for data from a comparable location, because there is no quantity. I mean, you can, if you want to make a lot of money, but you have to spend a lot of money, you could come up with Just like there's a SEPC associated with time, you could come up with a SEPC associated with area, right? So you could have a number for the cost in New York. Yeah.
Would that fall under the same guidelines of like different states have EPA regulations?
That's the problem, that the geographical factors depend very strongly on lots of things, including the politics, cost of real estate, availability of raw material, cost of utilities. So it's not like one area will be expensive for all types of industry. Yeah?
So if we go to make a plant that's using hydrogen somewhere, are people not going to want it there because hydrogen is explosive, not going to possible?
It's certainly possible. So there are local factors or local politics, but people would want you there for another reason. They may not want you for hydrogen. Why would they want you there? Jobs. Right? So again, chemical industry, where it is located, politics plays a very important role in that as well. Yeah.
So does the SEPC account for like rapid changes in market, like say the house market crash and stuff like that?
SEPC can never take into account rapid changes because it's just historical data. If there were rapid changes in the market at that point in time, it will take into account. So for instance, if you look at SEPC values historically, for instance, during the presidency of Jimmy Carter, what do you think you'll see for happening to SEPC? Skyrocketing, right? So yes, it is reflected, but it's not a short-time change. It's time scale of a year. But over a time scale of a year, if there were significant changes in the economy, it will be reflected. In fact, it's a very interesting, again, it seems politics can never escape our discussion if you're talking about money, but it's an interesting exercise to plot SEPC as a function of time and then draw bars of who was the president for that particular time. And then if you are very politically leaning, then figure out whether it was a Democrat or Republican. Because there are various arguments made about the impact the president had on the economy of the country. Like, of course, some people claim, and again, I'm not going to say whether it's true or not, that the economic boom during Clinton was attributed to, actually not even that, even before that, Ronald Reagan. What did Ronald Reagan do?
Cut taxes.
He cut taxes like crazy, just completely slashed the taxes. I thought it was amazing. I mean, I can't believe a president could do that, and because he must have, I think it worked out okay. It wasn't a disaster, but it was a rapid decrease in taxation. So some people claim that led to the growth in the long term during Clinton years. Again, I'm not an economist. I have no idea what is the validity of that claim, or for that instance, how could you prove the validity of a claim like that? But either way, it's just interesting. So if you, I know you have no time, but if you do decide to apply to the US grad schools, the extra time you get from that, or if the rest of you, if you don't want to, I don't know, you go clubbing one less time, or go to one less football game, or leave after half time if Gators are already winning, and then make this plot. I would be very interesting to look at. I would be interested in looking at it. Okay. I've never actually looked at it, but yeah, if anybody really likes politics, it could be an interesting discussion. All right, any questions? No? Okay, good. All right, so we are all set. So this way, we can cost it, and we have a number, right? So by the way, this kind of estimate is called order of magnitude estimate. As you can imagine, it's an order of magnitude estimate, right? Rate of estimate. So it's called order of magnitude estimate, as the word suggests. Now, let's say that you do an order of magnitude estimate. So just like building a house, right? You do this estimate, and it gives you a number of, okay, $500,000. Will you say, okay, now let's build it? No, what are you going to do then?
You're going to make it more specific.
Then you're going to say, okay, $500,000 seems reasonable to me. I can afford it. Let's not design the house, right? That's exactly what we do with this. So now we're going to go into a little bit more details, and we're going to draw so this is what is called a block flow diagram. Now we're going to do what is called a process flow diagram for this. Okay? And the process flow diagram obviously will have a few more details into it. Okay, so let's erase all this and let's draw a process flow diagram for this process. What example do you have?
Jared. Fuck you. Oh, I thought you were going down.